This tutorial will cover section 9.7 of the asteroid program, and also probably go into 9.8, and we are going to be adding a second weapon called the proton wave. Early on, we asked you to kind of play around with the program to see what different components did, and you should have discovered that right now the proton wave doesn't do anything. So we are going to examine the source code and take a look at the proton wave and its initial size. So let's open that code and see what it looks like. So the proton wave has a damage level of 30. Again, please notice the use of a constant that's named capital with all capital letters, and final indicates that it's a constant. The keyword static here means it's going to be accessible throughout the entire program as well. And we also have a static number of images and greenfoot images. And in this case, it says this is static, so the images are not recreated for every object. And so when they use that keyword static, it basically means it's declared once and defined and then used throughout the entire program, will not be recreated for every object. The proton wave, its constructor will initialize the images, and this initialize image code, if we take a look at it to try to kind of understand what it's doing, it has if the image is equal to null, then we're going to take a greenfoot image, and it's called a base image. We're going to say images is assigned a new greenfoot image bracket number of images. This creates an array. And when we worked with arrays before, we've had arrays of strings, we might have had arrays with numbers, but we've never had an array of objects. And this is going to be an array of images. And then I is going to start at 0. As long as it's less than the number of images, it's going to execute this loop. It's going to set an initial size of I plus 1. So it starts at 0 plus 1, so that's 1. And then the first image, image sub 0, is going to be our new greenfoot image. Images sub 0 dot scale is set to the size, and then we're going to increment. So as we go through, what this does is for index 1, then we have size is 1 plus 1, image sub 1, images sub 1 dot scale, and basically what it does is it's going to grow an image from a index of 0 up through number of images that we want, which is kind of unique. We've never done anything like this before. One of the first things that our textbook is going to have us do, let's take a look, and it's talking about this same code here, and this shows an visualization of the growing proton wave. So the first array index has a little proton wave, the next one is a little bit bigger, all the way up to the last 29th index, but it's the 30th image. Remember, there's always this off by 1 error. The method will scale up, and so it's going to fill an array with all of those images. So it talks through that a little bit more. But it's also going to then encourage us to use what's called a for loop rather than the while loop, because we know the beginning value and the ending value for the proton wave. A for loop is actually better in this instance. So the first exercise that they want you to do with this actual code is to rewrite the for loop. It's exercise 9.50 in your textbook. This same loop here. And basically, remember, for the for loop, you have 3 components. You have the initialization, you have the guard, and you have the update, all in one shortcut notation. So our initialization is this part. I'm going to cut it and paste it here. Could probably just as easily retype it. The guard is I less than number of images. The guard doesn't change. As long as that's true, it's going to execute. And then the update is this I plus plus, and the I plus plus, remember, adds 1. I don't need the semicolon at the end. And then I have a beginning brace for my for. We're going to eliminate the while. And I have the ending brace for my for. And so I just rewrote that while loop as a for loop. You have your initialization, your guard, and the update all in one nice compact statement. Next, we are going to actually create a proton wave in the constructor, or at least get it initialized or started. And that is, when a proton wave begins, we want to start with the smallest image. So we're going to set the images to images bracket 0. So we're going to set the first image to images bracket 0. And so that will begin our image at the smallest. It says next we want to create an instance field called current image. So an instance field is usually private. So it says to make it a data type int, and it's going to hold the current image. And right now, when we initialize or when we create a proton wave, it's going to start at 0. And basically, that's going to be the index. So that number is going to increase as a proton wave grows. We're also going to create a method stub for a new method called grow, because we're going to want to grow the proton wave. Initialize images only sets the images. So we want to actually make the images grow. So we need to create a method for that. That method, because it's only used by this class, will be called grow. And it has no parameters, no return values. And we're going to call the grow method from the act method, even though it doesn't do anything right now. And I'm just following along with the directions in the textbook. So we just went through exercises 51 through 54 in your textbook. We're getting very close, it says, to being done. We would need to, every time we need to implement the grow method, and every time we basically go through, or when we grow, we're going to start with the smallest image and work our way up to the largest image. And so we need to start at 0, which we already have set, and make it grow. But we don't want to always make the proton wave grow. We want to have it based upon some conditions. And so the suggestion is we're going to show the image at the current index, and we're going to increment the image. And that's going to be based upon the following condition. It's going to look like this. If the current image is greater than or equal to number images, that means we're done. And so it's only going to grow as long as the current image is smaller than the number of images. And if we're done, we're going to access the current world and remove the proton wave. So we're going to remove the object. This is a keyword that represents the current object, and since we're in the proton wave class, that current object is the proton wave. Otherwise, we're going to set the image to images bracket current image bracket parentheses semicolon, and then we're going to increment the current images. So that's current image plus plus will increase by 1. So basically, it's not a loop because there's no for statement, there's no while statement, but because it gets called from the act method on a repeating basis, if there's a proton wave, the act method is going to make it execute, and it will increment this and it will work its way through the array, through all the different images that were created. It's about time to try this out. So let's give it a shot. We're going to cross our fingers that it compiles. Without error, although it must have an error and I just can't see it here, so hold on. Image has private access and Greenfoot actor. I believe that should be images, which is plural. So we will try this again. Now the class compiled. If we go back to our scenario and we run it and we try a proton wave. Actually, what I need to do is bring a proton wave in over here, and you can see that it grows. Let me reset that. And we don't want the spaceship to die yet. We're going to put in a proton wave, and you can see the proton wave grow and then disappear. So that's the way a proton wave is supposed to work. There's a few more things that we're going to do with it, but that's it for this video.